Hello there guys and welcome to class.
And where did I go wrong? I lost a friend somewhere along.
Teacher Krishna here and we are working on the science subject. Let's go over our presentation and let's start with the topic in ending mind for today. Lesson number 3, surface water and groundwater. And the ending mind is following: clarify general information in key aspects from the topic, surface water and groundwater, to identify main water resources in Guatemala. Here you have a summary of the activities that you have to complete. Number 1, read lesson number 3, surface water and groundwater, and highlight the most relevant information. And you need to write a small summary with the gathered information and add pictures related to the surface water and groundwater resources that can be found in Guatemala. That's very important. Please remember to include pictures of groundwater and surface water resources that we find in our country. Okay, and today you might discover new things about your country, which is pretty interesting. Alright, so let's start with our topic, and we have the question: where on Earth is fresh water found? So, only 3% of Earth's water is fresh water, and most of it is frozen as ice and snow. So, only about 1% of Earth's water is fresh liquid water. That's very interesting to analyze because, well, imagine if we only have 1% of the type of water that is actually usable for humans, then we really have to take care of it, right? Because we have very little water to take into account. This fresh liquid water is found both on and below Earth's surface. And this tiny percentage of Earth's water must meet the large demand that all living things have for fresh and clean water. So all living things require fresh water in order to survive. And also we have to compare fresh water to salty water that we find in oceans. And the water that we have in oceans is water that humans and other living things cannot actually consume. So, well, at least some living things cannot consume. So that's why fresh water is very important. So water that collects on Earth's surface is called surface water. It is found in streams, rivers, and lakes. It may begin as precipitation in the form of rain, snow, sleet, or hail. And on Earth's surface, it flows from higher ground to lower ground. The water that flows across Earth's surface is called runoff. Eventually, runoff can enter bodies of water. This is something that we have studied in the water cycle. There is a lot of water that is actually evaporated, and once it comes to the ground, then it becomes a runoff, when it starts flowing down mountains, volcanoes, etc. Okay, so some rainwater and water from streams seeps down into the ground, collecting in spaces between rock particles. Water found in the spaces between rock particles below Earth's surface is called groundwater. And the water table is the upper boundary of the rock or sediment that is saturated with water. We learned about this specific word, which is infiltration. So when it rains, there is some water that is going to, enter the ground, and that is going to be stored in several rocks. That's why we call it groundwater. And the water table is the upper layer where the rocks are stored in water. So how does fresh water move through this environment? Think about it. And go ahead, try to complete this small exercise, and we're going to discuss more about it in the live session. Please have that in mind. And we will discuss this question in class, but you all are pretty smart kids, so it will be pretty simple for you. Alright, let's continue. So, water trickling down a hillside may flow together to form a stream, eroding soil and rock to make a channel. So, streams are like small rivers, let's say, but very, very small rivers that carry out water and that end up in a bigger body of water, such as other rivers or lakes. A channel is the path that a stream follows over time, and the channel gets wider and deeper as the stream erodes rock and soil. Streams typically flow along weaknesses in bedrock. Right, and a tributary is a smaller stream that feeds into a river and eventually into a river system. So tributaries are similar to streams, let's say. Again, they are small portions of water that end up in a bigger water system. A river system is a network of streams and rivers that drains an area of its runoff. Now, a watershed is the area of land drained by a river system. Streams, rivers, floodplains, lakes, ponds, wetlands, and groundwater all contribute water to a watershed. Watersheds are separated from one another by a ridge or an area of higher ground called a divide. Oh, and advice, please, you can go ahead and take notes of the most important words right here. For example, watershed, what is a watershed? A divide, what is a divide? You can write it down in your notebook because we are going to discuss that in our live session as well. Okay, we have a gradient. It's a measure of the change in elevation over a certain distance. In other words, it is a measure of the slope of the land. So how are we going to change the elevation from one place to another? For example, this place can be lower than this place. That's what we can call the gradient. A river's flow is the amount of water that moves through the river channel in a given amount of time. So how much water is going to go through the river or through the body of water? Materials carried by a stream are called streamloads. Rivers eventually deposited their streamloads downstream. So the materials that it is carrying out, such as rocks or plant particles, are what we call streamloads. Now, please identify the tributary, the river, the divide, the load, and watershed in the environment below. So, go ahead, try it out, and then we'll discuss about it. And this will be the teacher if you identify all parts correctly. Let's continue. How does groundwater flow? The water trickles down from the surface and reaches a rock layer with no pores or cracks, and the water pools to form an aquifer. So, there are some rocks that can actually storage water, while there are some other rocks that cannot storage water. So in those rocks where actually water cannot go through, then it is going to start flowing right at the top of them. And an aquifer is a rock layer that stores groundwater and allows the flow of groundwater. So aquifers are the type of rock that can actually save or conserve some water inside them. And the water table can rise or fall depending on the amount of water in the aquifer. An aquifer stores water in open spaces or pores between particles of rock or soil. Just like I was telling you, there are some rocks that have some pores, so they allow water to go through them. While there are others that are pretty tight and they are pretty closed, so water cannot go through them. The storage space in an aquifer is measured by porosity, which is the percentage of the rock that is composed of pore space. Meaning that there are some rocks that have bigger pores than others. So the bigger the pores are, then the more water the soil can store. The greater the pore space is, the higher the porosity is. Right? Permeability is a measure of how easily water can flow through an aquifer. That's very important. Permeability. High permeability means that the pores in the aquifer are connected to one another, so that water can flow easily. Let's suppose that we have a lot of rocks that are tying up together. So when their pores actually connect and they let water flow through them, then they are going to have a high permeability. A useful aquifer has both high porosity and high permeability. and gauge the extent of porosity and permeability, high or low, in each image. So identify the porosity. Which one do you think has a higher porosity? And of course, which one has a higher permeability? Try it out and we'll discuss that in a moment. The process by which surface water trickles down and enters an aquifer is called recharge. It occurs in an area called the recharge zone. The process by which groundwater becomes surface water is called discharge, and it happens in discharge zones. Through discharge and recharge, the same water circulates between surface water and groundwater. So let's say that if it rains a lot and a lot of water goes through a specific part, that is recharged because it is gaining water. But if the water is extracted and it goes to the overground, let's say, then that is discharged because we are subtracting or taking water from that specific resource. So now go ahead and label the discharge and recharge zones of the aquifer. Where do you think is going to happen the discharge, and where do you think is going to happen the recharge? And I know it may seem a little bit confusing, but don't worry, I will help you out in the live session. Let's continue. Making a splash. How do people use surface water and groundwater? In a typical home, about 50% of all water used is for washing clothes, bathing, washing dishes, and flushing toilets. Think about it. How are you using water in your house right now? So when you take a shower, you use water. When you do the dishes, you are using water. What else? What comes to your mind when using water? About 33% is used to water lawns and gardens. The rest is used for drinking, cooking, and washing hands. In the United States, about 40% of fresh water is used for agricultural activities, like growing crops and raising livestock. That's also important to consider. I was reading an article where they mentioned that the amount of water that we use is not really for, let's say, daily and common uses, just like the ones that we have at home, like taking a shower, bathing, using the bathroom, but actually it is used to irrigate or to water different plants. And especially in the United States, they use a lot of water just for growing up different plants and actually have a big enough supply of food for the population, and of course for exporting to other countries. About 45% of the fresh water used in the United States is used for industry. That's another important thing. Surface water in rivers, streams, and lakes is used to transport products and people, and for various recreational activities. And the limited supply of fresh water must be managed to meet the demands of a growing population. Scientists estimate that about 1 billion people around the world do not have an adequate supply of clean and fresh water. That's when we start to think a little bit more about our context. Do you think there are people in our country that don't have an adequate supply of clean water? Well, in fact, yes, unfortunately in our country there are many people that don't have access to clean water. Imagine how sad that is. Well, right now we are living like in the center of our department. But if we go to towns that are a little bit more isolated, most of them don't even have a clean water. So they have to access rivers and other water resources around in order to have access to this very important resource. Scientists are developing technologies to obtain clean, fresh water to meet global needs. So, see you in class, guys. And just before we go, this will be humans if we don't take care of our water and cannot get any more of it.
No, God! No, God, please, no! 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 No!